Too loud. Anyway, this is going to be a quick session. Basically, what I'm going to do in here, I sent already an announcement earlier concerning what we're going to be covering today. Basically, we're introducing Chapter 11. And also, there were quite a few things that I did in the past few days, namely the grades now, they're actually weighted. So based on what we agreed on in the syllabus, there were assignments that were added, and there were assignments actually that were changed the due dates on them. So there were a lot of changes that I made, and I want you guys to be aware of them. Okay, what's wrong with Jennifer now? She's sending a message. Let me check quickly, guys, okay, to see what she wants, okay? Hopefully she's not having a problem connecting. Okay, so that's another issue. Anyway, I'm hoping that everybody's in here. Again, I sent a message to several of you today concerning the project because apparently some of you, of course, did not do the project, and that's, of course, they received the mark of 0. Others actually did the project, but they submitted the file, and I think the problem with the file is the fact that I told you that this is a fillable file. First, you need to save it, and once you save it, that is when you make sure, you look at it to make sure that the content that you did is there, and then you upload it again. Because if you just go ahead and upload it without saving it, or if you forget to do one of the requirements, I think the requirement then was the name, and also the overall goal and the conclusion. So if you forget to put one of those, the file won't save, even though probably you worked so hard on it. So please make sure you do that. And this is actually the reason why I extended that is because we still have another project also. So I want to make sure that you guys are aware of this problem. So I should have graded this a long time ago. The problem was, as you guys are aware, we were in transition actually when the project was due, going from the face-to-face to the online instruction. So I did not grade it until now because, again, we were going through that transition, and I made sure that you get the grade on it before the project to make sure that you also know what to do. On overall, I mean, the people who received the grade was like averaging about 92 or 93%, so it was not bad. It's only those who did not submit their project or those who submitted, and there were about 4 or 5 people who submitted it with a blank report. So that resulted basically in a mark of 0. So I want you guys to make sure that, first of all, to fix it because I extended the deadline on that, and also to make sure that doesn't happen with the next project, namely the project that is due next week. That is one thing. The other thing also is that there are 2 assignments concerning chapters 7 and 8 that are due next week too. They are short assignments, but you have plenty of time to work on them, and they're all basically fill in the blanks, basically. So you're going to go through the questions and answer them and basically research the topic and answer them. They're not projects, they're straight out from the book. There is also, of course, the project that I'm hoping that you guys are done with it and you're submitting it too. And the other thing which is actually happening today around 2:30, and that is the quiz from chapter 10, which is due today at 10 p.m. I know some of you mentioned the fact that they're working, but I hope that you guys have taken care of that in the sense that you have allotted yourself at least the time to do this quiz because it's graded again. All of these things are impacting your grade, so I want to make sure that you guys are all aware of these things. The other thing to say is that there will be more, at least 2, potentially 3 more homework assignments concerning chapters 11, 12, and 10. But I may opt out of chapter 10 because we have a very heavy quiz on it. So it's still not decided yet, but that's basically in terms of what you look at. Of course, we still have the quizzes, the participation quizzes for chapters 11 and 12, and we still have a big exam coming in addition to all of the other assignments. So I'm hoping that you guys are ready for all of the things in terms of the things that are coming. Any questions in terms of these things? Because The grade now is more reflective of the actual average. So because all of the assignments have been grouped in their appropriate places and they are weighted in the overall grade. Now, the grade granted is very low for some of you, and it's because of the fact that actually the project was a big culprit for that. And all of the others, they are averaged, so they are going to be added, and they should be in your overall grade. There was also a message that they sent early in the week concerning the deadline tomorrow for you to decide if you want to drop with a W. That is actually also an option. You have to be aware of it. So hopefully you pass the word so that everybody is aware of it, so that we don't have any surprises at the end of the semester or a few years from now when you see that you have a grade that was marked the way that you thought it should not have marked. Anyway, so that's basically in terms of the administrative stuff that I was going to talk to you about. Unless you guys have any questions. Do you have any specific questions that we may talk about, especially in terms of these two new types of assignments that have popped up, basically?
No, from me.
Okay. Okay, so I'm hoping that you guys are going to take care of all of these things. I know it's a lot of stuff to do, but that's part of the learning process, is that you have to do things. You can't just be basically passive in a sense, that just seeing how things work without having to actually get your hands dirty and learn them. So that's basically in a nutshell what's going on. And so the topic today, as you can see from the picture behind me, actually it's an animation behind me, is going to be the gas giants, all of the basically the 4 planets. I included actually in the animation. I don't know if it's going to restart or not. Let me see if I can do it right now. Okay, let me see if I can go and stop my video and then restart it to see. Okay, so what you see in here, including this one in here, the one behind me immediately, that's actually planet 9. So, and the smaller one is Uranus, and the other one, Neptune, the blue ones, and of course the 2 big ones are Jupiter and Saturn. Of course, I put them very close for one another, so when I started the animation, they immediately collapsed, including planet 9, that eventually also collapses on Jupiter, and Jupiter is a big player, and that's basically the theme of this. Even if you put them next to one another, and you saw earlier actually in the size, at least physically, Saturn is not that different from Jupiter in terms of the size, the physical size, how big it is. It's about 10,000 kilometers less in radius, which is a lot. I mean, the Earth is not that much in radius, but compared to their sizes, one of them is about 70,000 kilometers and the other one is about 60,000 kilometers in radius. That's not diameter. That's just half the distance. So it's basically 140,000 kilometers from edge to from end to end. Basically, if you run through Jupiter. So these things are big and huge. And the point being in here is that their size, especially the size of Jupiter, is bigger than anything else in the solar system. So that's basically the common theme for this thing. Their composition is similar. Their positions in the solar system, relatively speaking, is similar. They are beyond a point in the solar system, which we call the, let me get this thing going while we're talking, because sometimes it takes time for it to start. I happen to mention, okay. So basically, beyond the first line, beyond the point with which, from which the basically water does not exist in the liquid form, it's in solid form. Unless it's way inside some sort of a heated environment, it's going to be in a solid form, in the form of ice, basically. So let me see if it started. So yeah, so let me go back in here and share with you the overall view picture that we are looking at for the solar system. Share screen, and it's going to be this one in here. Okay, and as you can see in here, I have all of the planets. The sun is in the middle, and everything else is revolving around the sun. And there is a point, of course, you can see Jupiter in here slowly moving. Next to it in here, way here on the other edge is Saturn. And you don't see Uranus or Neptune because they are far further away. So I have to zoom out actually. So there is a line in here between Mars and Jupiter, somewhere midway, where we call it the frost line, where actually water, the temperature drops low enough so that water does not stay in the solid form. So what you have in here, and I'm not sure if we're going to cover the comets. When a comet comes from the far away edges of the solar system, it's solid ice basically. But then, well, the minute it passes this point, which is where Jupiter is, which is about 5 astronomical units, it starts to heat up and starts to form a halo around it. And the halo starts to increase the closer it gets to the sun, and actually forms a tail because of the solar wind. And then it's going to go around the sun, and that tail basically is following it. And then at the end, it's going to freeze again the minute it passes that frost line. And at that point, basically, it's going to go again, solid form, basically ice form again, into the outside, in the outer edges of the solar system and come back again. So that's basically how comets form, and that's why we see them. They have tails. So the point being in here is that anything beyond the frost line is what we're going to be talking about today. We have 4 culprits. I know the animation includes Planet 9, and Planet 9 is still hypothetical planet. So don't take it as if it's something that we know exists for sure. As a matter of fact, there is another hypothesis that Planet 9 doesn't exist at all. Or there is probably a black hole from the early universe. When the universe was formed, there was something called primordial black holes, and this could very well be the one that is impacting the motion of the dwarf planets in the outer edges of the solar system. That it looks like it's a planet, and probably the reason why we cannot see it is because probably it's a black hole, and it's so small that we cannot see that black hole because the bigger they are. I mean, the smaller they are, even though it's a black hole, it's going to be very small because it's condensed in one point. Okay, where is the other planets? Oh man, you have to zoom very far. Here is Uranus, okay, and here is Neptune. So those are the 4 objects that we're going to be looking at today. So basically, I know I have the animation behind me, but I just want to start something in here just to give you, I know the book has it too, just to give you a visual of how big these things are. I mean, just the relatively speaking, of course, compared to one another. The distances are huge. It's 5 astronomical units just when you get into the, by the time you reach Jupiter. That means it's 5 times further away from the sun than the Earth is. That's what where Jupiter is. So imagine yourself going to go to Mars. Mars takes about 6 months, for example, 7 months to get there to it, and depending on the path, of course, sometimes it takes longer. And that's about an astronomical unit between the Earth and Mars. So you still have 3 times as much to reach just Jupiter, just to get into the, or 4 as much, sorry. No, 3 as much, because from here to it is about 4 astronomical units. At least stretched out, I mean, depending on our position with respect to the sun, of course. The point being in here is that still does not get you halfway, or just about halfway to get to Saturn. So Saturn is very, very, very far compared to Jupiter, and that is still small compared to where Uranus or even where Neptune is. So this is, in terms of distances, they are huge, and that's really what the visual is. So if you want to, from this distance where we are at Neptune's orbit, I don't know how far we are from towards Neptune, so let me check in here. It says in here, distance to, we are 45 astronomical units from Neptune, so we need to get closer to it. So we are about 3 astronomical units. This is how Neptune would look like. So we are now in the kilometers. So basically we're closer now. Of course, not the kilometers, I'm sorry. We are in the, what is it, millions of kilometers away. So it's still very far away from where Neptune is. This is the further object that we're going to be studying today, now we're very close. We're about 800,000 kilometers, less than 1 million kilometers away from it. We're getting closer. So at this point, we are very close. We are about 200,000 kilometers. This is slightly further than what the moon is from the Earth. So we are inside the orbit of the Earth compared to where that is. So we are now very up close to 65,000 kilometers. Is very, very close from it. This is basically what Neptune looks like. Again, this is depending on the day or night. So this is the visual of what Neptune looks like, and it's this bluish color. And we're going to talk about why this is that color basically. And again, it's its constitution that gives it its color. This is some of its physical properties, basically its surface temperature and how big it is compared to the Earth. 17 times the mass of the Earth. It's a big planet, okay? And then its diameter, it's a radius. The distance from this point to the middle is about 24,600 kilometers. Remember, the Earth is about 6,400 kilometers. So this is big compared to the Earth. Now, this is one of the objects that we're going to be exploring in this chapter. So let me zoom out again. So on the next object, let me remove the tail in here because I don't like the tail in here. Oops. Oh man, it's probably 3 days, so I can't really do that to it right now. Okay, forget about it for right now, okay? Let me stop the animation. Let's move out. I'm zooming out right now, okay? So what is the next one? Uranus. This is the solar system, looking at it from the top, okay? Now we're in Uranus. Let's come closer to it again. Again, you can look at the distance to it is about 4 astronomical units right now. So it's very far. This is about 200 million kilometers. It's very far. Now we're getting closer to it. The Uranus is a little bit smaller actually than Neptune. It's 14 times. Remember, Neptune was 17 times the mass of the Earth. This is slightly less than that, about 3 times the Earth, basically, difference between them. And it's slightly bigger, actually, in radius, 25,000 kilometers, which tells you something about the density, which we should discover. So this should be less dense than Neptune is. So Neptune has more density from whatever it has. If you're interested in the composition, of course, you can see the composition. And we're going to talk about the composition, which is mainly an icy thing. That's basically what Neptune is. What Uranus is. And that's another object that the density is 1.27 gram per cubic centimeter. So the density in here is not, remember when we were doing when we're dealing with the inner object, the inner planets, basically the least dense of the planets was of course Mars, and Mars was 3.9. So it was almost 4 times as big as what the density of Uranus is. That tells you a lot about its composition. If you're curious, and I know we didn't talk about that for Neptune, Neptune's density must be higher, slightly higher than this number. And it's because it has more mass and less volume. Remember, density is mass over volume. So that's basically how we can figure these numbers out. And then, of course, we have Saturn. I'm going to zoom to it, forget about the composition. I'm going to go just to the overview of the planet. Now we are very close to Saturn. Actually, we passed even probably we don't see the rings in here, and that's by design. So this is how a planet, let me zoom out a little bit. This is basically how the planets look like from each side of it. So you can go look at it, look at the North Pole, the South Pole. And we're going to have more pictures from the different missions that went in there and gave us these beautiful pictures of this planet. One of the we're going to be exploring and actually the moon Titan is one of the moons that actually landed on. So this is not man-made, of course. We sent a robot there, so that's something that it was a Huygens, basically part of the was it the Cassini? Yeah, the Cassini and Huygens, they went together. And the Cassini and Huygens, they separated, and Huygens landed on Titan with a parachute. So that's collected a lot of data and gave us about an hour and a half basically worth of data from the moon itself. So that's an interesting thought. I mean, as far as Cassini itself, it went down into the atmosphere and burned in 2017. I think it was October 2017, if I remember correctly, because I was actually that. And then we have a last object that we're going to be looking at. Actually, the first object we're going to start with because it's closer to us, and it's the biggest player in the solar system by far. If you take all of the planets of the solar system, they don't amount to what Jupiter is. So that's Jupiter. Again, it has its properties, which I'm going to put right away. It's 318 times the mass of the Earth. So it's the biggest object in the solar system, of course, after the Sun. And it's about 70,000 kilometers in radius. The distance from this point, the edge of Jupiter to the middle is 70,000. So edge to edge is about 140,000. And of course, it's characterized by this thing in here, which is a storm that's been happening for a long time. One of the things that we looked at in terms of Saturn, in terms of Jupiter, is its poles too. And we will talk about the rotation of this object and how they move and things like that. We are about 5 astronomical distance to the closest star. I'm sorry, to the closest star, yes, to the Sun. The data today, because this planet, let me check the motion. This planet the semi-major axis is 5.2. That is the distance on average between it and the Sun, and it fluctuates between almost 5 astronomical units. So it can get very close at 4.95 astronomical units, and it's far away at 5.45. Basically, because the path is elliptic, not actually circular path. And that is typical for all of the planets. And the eccentricity is very low, of course. That's an indicative of how eccentric this object is. So that's basically it has 4 interesting moons, but we're hopefully, I don't think that we're going to cover them in this class at all, but hopefully down the road we will be able to cover them, and we will talk more about their properties. So this is in a nutshell, basically the 4 objects that we're going to be talking about. I know in the animation behind me, in the movie behind me, basically, I included, what is it? There, Planet 9, which is by itself in the bottom in there, but that's actually a hypothetical object, so it's not real. Okay, we don't know. We know it's there, but we don't know how it looks like or what it's. We know it's big if it's a planet, and if it's not a planet, it's probably a black hole or something big. Other than that, which we're not going to cover, everything else should be able to cover. And this is the chapter that we have before us. So I promised you guys that we're going to do only about half an hour, basically, onto the introduction only. And because we have a quiz that is going to start in about 5 minutes or so. So I want you guys to take care of that, because some of you are working, some of you have other obligations, so I don't want to really intrude on their times or other things. So I want you guys to take care of that quiz, because it has in terms of your grade. Let me check the attendance, because I promise that needs to be done too. Okay. The grades for those who came in late, I know we started with few, now we have more people who joined us, should be more reflective of what they need to be. Now, there is actually, I don't see, she's not here. Okay. If you need help with the homework assignment for the 2 chapters, please do ask, okay? I'm available. You can email me. Usually, and I don't know if I ever replied late, last week I had problems with my other laptop, so I didn't reply in time, and I was struggling trying to get back on board. Now, since I have this one working, so I'm good. So please send me. I should respond right away to you, answer whatever questions you have. I don't want you to fall behind on your work. I really want you to earn your grade and get it, and earn whatever you need to. For those who did not submit the project again or had issues with submitting it, please submit it again. Because, like I said, the grades were not there. They were averaging between 92 to 93%. That should be actually good for your grade overall. So do that. submit the project that was the retrograde motion, and also make sure you submit the one for the lunar observations. And also you have several assignments, so please take care of them and communicate with me. I try to be usually responsive immediately, even sometimes at late at night when I am if I am awake, I answer. If not, the first thing in the morning, usually I try to answer right away. Does this sound? Or do you have any questions? Okay. Andrew, Brandon, Ariana, everybody else agrees with them, hopefully. Then I will let you go because you have a quiz. And then Tuesday, we're going to meet again during the same time at 2 o'clock. Hopefully we advance very much in chapter 11. And then if not, we still have Thursday where we have to deal with chapter 11, introduce chapter 12, and there will be peak quizzes on them, participation quizzes, similar to what we did with the previous chapters, chapter 8 and 9. Not like what we're doing with chapter 10. There will be no extensive one in time, and you have to do it. You have 3 chances, and all of that nonsense stuff, and with a million questions or some, more of a way of doing it, and you have time to answer the questions and things like that. Okay, I'll see you guys next Tuesday, and thank you for showing up. And I hope that I clarified some of the issues. And if it's still not clear, Alexis, Krista, anybody else, Sheridan, please send me messages. I will be more than happy to answer yours. Okay?
Thank you.
Okay, bye.
Thanks.